Hello, welcome to this lecture video. So our topic is linear equations and matrices. So I am teacher Melai, and in this lecture video, we are going to talk about what is a matrix and what are the different types of matrices. So let us move to our next slide. So what is a matrix? A matrix is a rectangular array with m of rows and n of columns. So it can be denoted as m times n matrix, or we can also use r raised to m times n or c raised to m times n, where r represents real numbers and c represents complex numbers. So which means that when we are using r to name our matrix, it means that the entries are real numbers. While if it is c, it means that our entries are complex numbers. Aside from real numbers or complex numbers, other entries can also be functions, variables, or polynomials. And we can use the capital letters of the alphabet A, B, C, D to name or to call our matrix. So we can call matrix A, matrix B, matrix C, and others. So here is an example or how our matrix look like. So for instance, this is matrix A. So A is equal to I sub 1, 1, or we can also make use of A sub Mn, where M represents the number of rows as mentioned and N represents the number of columns. So as you consider, for example, A sub 1, 1, this means that it is located at row number 1, column number 1. So as we move to the next column, so of course, the value of n is also moving. So from 2, from 3, and all others until to the last entry here, which is a sub 1n. So it is called a sub mn as mentioned because m represents the mth row and n represents the nth row. So we call the dimension or m times n also as order of matrix. So we have here example. So example number 1. So we have 2 rows and 2 columns. Example number 2. So we have 3 rows, 1 column. Example number 3. 1 row with 3 columns. Let's go back to example number 1. So for example number 1, the order of this is 2 times 2, or 2 by 2, which represents now that the number of row as mentioned is 2 and the number of column is also 2. And this particular example is also called a square matrix. So whenever we encounter matrices with the same number of rows and columns, it of course forms a square, so we call it as square matrix. For example 2, it is 3 by 1, so it is also called column matrix, simply because of course it contains only one column. For example number 3, since we have 1 row, then the order of this is 1 by 3, and it is called the row matrix. So here are other types of matrices. So we can also come up with, or we also have the term identity matrix or unit matrix. So this is when the diagonal matrix is, the value of diagonal matrix is equal to 1. So we have here the diagonal matrix. And then aside from that, of course, the diagonal matrix is 1 and all other entries now are 0. For 0 or null matrix, so all the elements are 0. So it is shown in the example that the entries are all 0. While if it only contains one element, it is called single tone matrix. So aside from that, we also have what we call rectangular matrix. That is, of course, if the number of columns is not different with the number of row, or rather the number of row is different from the number of columns. So we have m is not equal to n. Now we have some special rectangular matrix. We call it as horizontal matrix and vertical matrix. So when will we know that it is a horizontal matrix? So if the number of columns is higher than the number of row, we call it as horizontal matrix. So in our first example, the number of columns here is 3 and the number of row is only 2. So that's why we call it as horizontal matrix. While for vertical matrix, the number of row is higher than the number of columns. So that's why we have here also 3 rows compared with 2 columns. Then we call this second example as vertical matrix. So what is diagonal matrix? So aside from all other matrices, we also have what we call a diagonal matrix. So as you can see here in the example, the principal diagonal contained elements that is not a 0, and all other elements are already 0. So it's called a diagonal matrix. For scalar matrix, as you can see, all the values in our diagonal are the same and the rest again is equal to 0, or all other elements are equal to 0. For triangular matrix, so the elements above or below the principal diagonal is 0. So we have upper triangular matrix and lower triangular matrix. So for the first one, the upper triangular, so if you notice here, all the values now below are equal to 0. So we have N3, it forms a triangle. It is upper triangular. While for the second one, the values zeros are located above. So it means that the triangle formed with N3 not equal to 0 is located below. So it means that it is a lower triangular matrix. For symmetric matrix, so we have A sub I sub j is equal to A sub j sub k. So this means that, for example, we have here A sub 1, 2. So our A sub 1, 2, column number 1, row number 2 is 3. So as you can see here, the value is, so let us use our, okay. So our value here is 3. And then, if we are going also to use A sub or see the value of row number 2, column number 1, it is also equal to 3. While if we consider A sub 1, 3, that is row 1, column 3, so 4, and 3 is 4, and 3, 1, it is also equal to 4. So it is a symmetric matrix. Okay, next. Skew symmetric matrix. So we also have what we call as skew symmetric matrix. This is when A sub I, ij is equal to the negative A sub jk. So all main diagonal entries are 0. So we have here the main diagonal, it is 0. While if we look at the value, for example, just like the first one, we have here A sub 1, 2. A sub 1, 2 is 6. And A sub 2, 1 is negative 6. So A sub 3, 1 is negative 4. A sub 1, 1, 3 is equal to 4. So it is a skew symmetric matrix. So what other types of matrices do you know? So there are actually a lot of different types of matrices, and also this mentioned matrices also involve some other properties that we are going to explore in another video. Thank you for watching.